First, I am taking all the header files, include stdih, stdlib, math, and time header files. This is the function that implements insertion sorting. It takes the pointer to the data set as a data array and a size variable. If we come down below, this is the merge function that is used by a merge sort algorithm. This is the merge function. In this, it takes the data array again. It takes the left pointer of being sorted, it takes the middle, and it takes the right. Here in merge sort, it again takes the data array, the left variable and the right variable. If the left variable is less than the right variable, then it gets the middle as the average of the two, and it sorts the left part first and then the right part. After sorting them, it merges them back using the function over here, in which it gets the left, middle, and right. First adds data from both left and right, and if some data is left over from either of those two, then it gets added at the end over here. Coming down, here is the implementation of quicksort. This is the quicksort partition function, which takes the data array pointer and the left and right as input. It finds the pivot at the right end, that is the end of the data of being sorted. You takes the left -1 as the I, and then it swaps data as needed. Same over here. This is quicksort function, main quicksort function. It also takes the data set and also takes the point to be started, where the sorting has to be started and where the sorting has to end. And this will be 0 and this will be n-1, size -1. And while left is right, less than right, then it finds the partition index, where partitioning has to be done using the qs partition function, and then it quicksorts from the left part, and then it quicksorts the right part. Now let's move to the heap sort. For heap sort, we need a structure called known as max heap. So it has a size, integer size to store its size, and a integer pointer to data. Now we can see here, if we come to the heap sort function, it takes that integer pointer to data and integer size. Then it creates a max heap using the create heap function, which allocates memory using malloc, puts the size and data in, and it max heapifies it, which calls this function to in this function max heapifies the data over here. This is the, and over here, after my creation of heap is completed, then it checks this condition. If the condition remains true, it will swap, and after swapping it will always run max heapify to again reheapify the heap. So that's how heap sort works. Coming down below, this is the utility function used to swap two elements. Void swap takes two integer pointers a and b, and it uses a third integer tmp and swaps them. Here is the utility function that is used to create a random data set. Void create data set. It takes a data pointer which points to an array, the start of an array, and it takes the size of, that is the number of data variables to be created, random data variables. Then it uses the srand function to create a seed. It uses time 0 as the seed for the srand function. This ensures that every time this rand function here gets run, it generates randomly unique values, otherwise it would generate the same values. So that seed ensures that it generates the new values and unique values. So this for loop runs, and that is from 0 to size -1. It generates size number of data values, random data values, and it prints out this message when a data set has been created. Now coming to the main function, in the main function we are creating two integer values, two integer variables, size and count. We input the size of the database set and the number of times you have to test, which is the count. We create a list over here which will store all the times in which the sorting has been done for each algorithm. So 30 times we are accounting for the count portion, and 4 times for the 4 width, that is the 4 different algorithms, and 30 is the number of tests. So if we come down over here, we can if we go to this for loop which is running from 0 to count minus 1, that is count number of tests, and it issues this system cls command which allows us to clear the screen. It prints out the current statement, like which test is being run and whether the data set is being created. Then it makes a array called original data, in which an integer pointer to data pointer points to original data, and it creates a data set. Now these are all the clock underscore t values which are defined to for calculating the time used by these functions, so these algorithms. So for that we are defining these values. Now we are copying all the data from the original data we just created using dataset into data, because we want that for each of the 4 algorithms the same dataset shall be used per test. Hence therefore it's being copied into data, and after that insertion sort before is equal to clock, the current clock, and the insertion sort is called, and as soon as that's finished then insertion sort after is equal to clock, and hence we got the difference. Same thing is repeated. We are first copying the data again because the data has been sorted now, so we are copying back again from the original array, that is the original data, to the data array, and then again we are doing repeating the same for merge sort. Similarly it goes on for quick sort and also for heap sort. So after all of this we are adding the values to the time list array which stores all the times. In this double we are implicitly converting into double, and we are subtracting the differences and dividing it by a constant known as clocks per second. Now if we come down, you can say that it's print compare, it's saying that it has completed this test, and just so that the user can read what is happening, we have added a sleep timer for 3 seconds. Now we are out of the for loop. In over here we can see it's again calling system cls to clear the screen. Now we are taking 4 variables for the average of each time, and we are running through the entirety of the array, and we are adding up all the times. After this what we are doing is over here is that we are printing it. After getting the times and the average, we are going here and we are printing the time gets printed with the average time taken by you. That's it. That's the end of the program.